Hey, good morning, YouTube. You're all having a great day. Gonna be working on the fantasy console today, as I have been on this entire stream set. But specifically, what I want to work on is the display aesthetics. Um, the the one thing is that trying to simulate a calculator. Hello, are you gonna work today? Um, see how well this scales. If it's going to work. Come on. There we go. I don't think that the screen as is here captures really well the aesthetics of the TI-83 calculator. I mean, there's some basic stuff going on, and I'm going above and beyond the TI-83 calculator too, but I'm obviously not. I'm going to start with the basis. So, like, if we look at a TI-83 calculator image, let's see if we can find one kind of high definition. Oh, you know what? I gotta do quick. Just bring my YouTube channel back up in case there's any comments. Let's see here. Here, we'll take this one for example, maybe, or okay, this one's perfect. So one of the things you can kind of note looking in here is that you could actually see the pixels, individual pixels. They were very blocky on the TI-83 calculator. And when we're doing our thing, even when we go to the, so this is the true display for the, matching or whatever. These are crisp, whereas these are definitely not crisp. And so I want to think about how I can make this look closer to this in the way that it's structured, or that it looks. One of the things you notice is that the actual pixel lines, you can see them. And I might not be able to achieve this for every single pixel or every single resolution that this supports. So, at this higher resolution, getting that fine grained with the pixels might not be really feasible. But I want to see today if I can replicate this feel and go that route. The other thing is that overall the color scheme here, the way this was constructed, is a little bit more, just overall a lot, more subdued, because it's not really backlit the way this is. I don't know if there's a way to achieve kind of a lower lighting, and then have the option to maybe turn on lower lighting or turn on backlighting. So that's something I'm thinking about. Okay. So looking at the pixels here, one of the things that I've noticed, like up close, is that there's definitely like, like one pixel is definitely, some of the pixels are definitely like lighter. So if I could, for each actual virtual pixel, create like a cluster of pixels and then toggle the colors on them just a little bit. So for instance, when you, like, you can see even with the ones that are on, like this N here, there's a little bit of burn in, I think, from that. There's just slight coloration distortions that make it, you know, feel way different than this here. So that's kind of what I'm going to look at achieving on this. So we'll see if I can do that. The first thing I'm going to do towards that end is to comment out the viewport adapter here and get rid of the natural scaling that's in, or the scaling that I've added to it based on resolution. Now I figured if I could do a 3x3 cluster of pixels, and then I have to begin this anyways. I think I want to keep this one. Then my actual resolution will be always so 96, you know, times 3 would be 288. So the screen is, did I get that right? I'm waking up this morning still. 96 by 64, yeah. So the largest supported resolution is 384. Now if we times that by 3, we're getting pretty close to the 1280. That is, if you're going to go yeah, so that's 128 or more. Interestingly enough, I could probably go all the way up to 1280. But then what happens with 256 times 3 is 7, goes above the 720p mark, which there's not a lot of monitors that are 720p nowadays. I have seen 900, like 1440 by 900, and there are laptops that are actually really small resolutions, like they stop at 768, I think. So I think that that would be about a perfect height, up and down, and then I can use the additional 128 on the sides, so 64 bits of pixels of like a bezel maybe. The other thing I could do here is actually make this top resolution not 384, and instead of doing 192 times 2, which is what gave me the 384, I could do 192 plus another 96 pixels, which would give me 288. That times 3 would keep me at 800. 128 plus 64 times 3, 5, so 800 some by. That would keep me in a better range. So 192 plus 6, or sorry, 92 plus 64, or sorry, 96 is 480, and that should be divisible by our width, which is 6 per, so that'd be 80 columns across, which is actually perfect for an editor. So I think that would be a better resolution overall, is to do 192 plus 96. So do a 288 as my top, and then this would be what is it, 128 plus, I've never been great at doing math in my head, so to anybody out there who is like me, who thinks you can't program if you can't do math in your head, it's very much not true. Okay, so I'm just going to get a feel for how that resolution looks then. So this is at the default resolution. So there, I forgot I took out the scaling, but you know, that's pretty good. And then that's the min resolution. So what I want to do is scale this up by taking the actual defining like a pixel as a individual image. And then what I want to do is draw that image across the screen in the positions. So what I might do here is actually switch this out so that I'm no longer plopping them into a texture and drawing. Instead, I'm literally going to be drawing individual pixels into it. So if I open up like paint.net, and we go, and what I'm talking about is a 3x3, very, very small image like this. That would represent the pixel. And then I believe what I could do, and let's see if I can find that image again. I closed it, so. And we went like a high definition, large. Yeah, this one. Okay. So I can take the concept of this being just like a colored like take something with just a little bit of shading like this here, and then adjust it based on so what we're talking about is probably doing something like so the thing I'm not really getting here is whether it's the first. So you can see the striping. Is this striping at the end of the pixel? I think it is. So do something like, if you could imagine an on one would be something like a lighter colored black, and then like a grayish. That would go like this. But they would be colored similar to this. So let's take a quick screenshot here of that. So maybe something in like this range right here. We'll go with like a range of pixels. And then something right there, maybe. So that's hardly noticeable. So let's go with like a little bit bigger. So let's go with a 9x9 and say, what would this look like if we extrapolated this across? And actually 9x9 is probably not quite right. What we really want to do is go 3 times 6, which is 18. And then our height is really 8 times 3, which is 24. Right? Yeah. And the reason for that is that's what a character will display at, which is all we're currently doing. And maybe I could, within the code for this, do some slight variations on the colorations of these. So, oh, come on. Yeah, that kind of gives the look at it. I don't know if that comes through really well on the stream or not, but that actually gives a pretty good look to the way that this is, just slight variations. Now, if I'm going to take something and start turning pixels on, which would be the dark shading that we get, so let's make a, I don't know, a T, ugly T maybe. Oh. So in these cases, it would first be, we'd shade in the, you know, I'll do this and then we'll just turn the tolerance way down. And turn off the, I think there's a way, there we go. So that starts like that, and then the off pixel for an on pixel has to be just a slight shade different. So something in this range probably. And those ones I do have to use the pencil for. This last one got messed up, but I'll fix it. Oh, jeez. So aesthetically, it would look something like that, which looks, again, you probably can't see it too well, but when I look at it, it looks a heck of a lot more like I'm actually looking at a T83 screen than if I'm looking at what I currently have. So now, interestingly enough, so when you're doing the off ones, it's brighter. Oh yeah, so it's always brighter. So it's 2 darkly shaded pixels, and I mean I could probably even do something where, you know, I take something that's kind of in the in-between here, and so this would be something just slightly lighter than that. So if I add a little bit of, say, bring it up a little bit, and then plop that in here. That looks too light. Maybe I'll take the outer one and make it darker. And then go that route. It adds even a little bit more level of depth to it. Yeah. So the idea here is that I start with a base color, which might be you know, this right here, or it could be any color. It could be green, it could be whatever. It's going to be a dark color anyways. So it might be like that. And then I have to go like slightly shade lighter for that one. And then a little bit lighter yet for the outer one. And that's how I would produce the actual pixel that gets plopped in here. And like I said, what I could do instead of actually, I can take the base color out of the display buffer, and then I can actually take an individual pixel texture that I create that's actually just like a shading thing, and then just combine the two. So I might be able to even use the well, if I don't include an actual black, I might actually be able to use just a mask color that sits on top of a But anyways, this is this is what I want to try to achieve today, is to make it actually look a little bit more realistic. So let's go down that path here and see what happens. So the idea would be, again, that I would get rid of, on the T83 side, I would get rid of this texture and this, and I would do an immediate mode kind of drawing of individual pixels that I then have to color. I could try using a shader for it, but I'm a little bit wary of shaders right now. So, not wary, but... So, if I took this in here and I said, let's say, computer.display.walk, and I don't have a content pipeline available to me, so I might actually still make a texture, or I didn't bring in the content pipeline to this project. So maybe I'll manually create this texture. Okay, so I still would have... I'll just make copies of these quick. This would be a pixel data, virtual pixel. So, and what this would be then is a virtual pixel would equal a new texture graphics device with a width of 3 and a height of 3. And virtual pixel data, new color array. That would be 9. So 3 times 3. So one way I could do this is to actually render, in one pass, render out the actual, sorry, I'm thinking about this, render out the pixel as a static color in a 3x3 grid. And I can optimize this too by pre-creating all of the textures for each individual color. because you'd have an on pixel, an off pixel, and then in each individual color. But the idea here would be that I could render out this base color first, which would be the lightest color, and then I could go around and put like another layer over that alpha blends in basically the actual like shading of it. Yeah, so and really that would just be this part right here would actually, but it would make sense to do it like that. I'm not sure what there's pre-multiplied alphas or something like that. That might be a little bit. Well, let's get it working. We can optimize it later. So how I'll do this is copy the color into the pixel data for each pixel, then draw it scaled out, and then on each pixel to draw a masked one. Just for the sake of trying this. Call it shade. Data. Actually, I don't need to store this data. It's something I should just have as a pixel. I can set up once. So it'd be like var data equals new. Nine by 9 color, or and how this will look is it'll be black with a an alpha associated with it. So I'll have to figure out what this represents here. So these will be the first row will be darkest, darkest, lightest, but to gauge the opacity here, oh, you know what I can do is I'll add a layer, and then I will take a pixel like this, I will color it black, and then I will adjust its opacity till I feel like it's about where I want it to be. Maybe there, about 150. A little darker than that. Still have the opacity checked, right? Oh, now it's all messed up. Let's go back in time here. Okay, so there's black. And then I would take that and I would bring it down to maybe like a 170. Then I would take this pixel and bring it out a little bit more. have to clear out the base color here of this particular pixel in the background to make it accurate, because there's already a little shading in there. Well, actually, in this one too, it wouldn't be that I want to go that dark. I want to go a lot lighter than that, because my base is all different. So let me take out this and start over with that. Okay, so if I take a pixel like these two, and then I shade them with black, and then I want to get them like this color, right, which is right next to it here. It's not going to be very much. Maybe like a 20. Yeah, I think 20 is probably not too bad. And then I would go slightly lighter, so maybe like a 25 for this pixel right here, or sorry, 15. Or maybe 10. Yeah, that gives a pretty good color. Okay, so then for a pixel that's on, it starts with a base color of something like that. Oh, something like that. And I was going to look at... There. So then we take the base color and we do the same mask over it. So we take black at a 20 opacity and we plop that over top. Now we take it at a 10. Now we drop it there. Now, that's not nearly as dark as I had it. So maybe I need to have a couple of different shades options here. So maybe a 20 would be good there. 30, maybe? Or I could just, I mean, I could scale the intensity based on how close to black the actual thing is. So, you know, when it's light like this, it's a lot lighter, but 40 and 30. It's pretty close to where I had it, I think. Yeah, that looks pretty close. So let's see how that looks like on a light pixel, though. Would be that, and then 40 would be something like that. So that would make it look kind of not quite right on a light pixel, though. So it would look like it's kind of shaded in. So what I might need to do is say, if this is a light pixel, then do 2010. Oh, sorry. Oh, you know what? Let me try this again, just to make sure there wasn't some cross shading going on. Yeah, that looks too dark. But 20. Interesting, it blends it. Which means I might be off on both of these, to be honest. So let's go with a 40 again. And then we'll drop our... that. See, it's actually not that dark, so I need to even go darker than that. I need to be like, maybe like 60. Oh. Darker. 80. 80 is pretty close. 90. 90 is probably about right on where I want to be. Let's maybe go with a 70. That's too dark. So it's half of 90, 45. Yeah, I think that's about good. Okay. But then for these smaller ones, I want to go with 20 and 10 to have it. Which will make it look apparent, but not on. I mean, theoretically, I could actually make a 96 by 64 because these are all scaled out. I could make a 96 by 64 mask of this and then import that in the content pipeline and then just overlay it instead of doing it pixel by pixel, which would be a way to optimize this. But so now if I took a color, any base color, and said, you know, if this is a green, I suppose the idea is that these ones are off. But what if I took a white and that's what this color was? That's how the pixel would look like. I don't think I'd ever have a pure white on here because it's too bright. But say if I had a really light gray. Oh, and I went to the background. Yeah, maybe white wouldn't be too bad. At proper resolution, which is 100%. Now the thing about white is that it should be like the background color here. It shouldn't be. Oh, weird. You can barely tell. It should have just a slight shade to it. It shouldn't actually be that visible. But in okay, so I do have to say, is this a light color or a dark color? And then adjust and use a different shade. So a 9045 or a 2010 is I think what I've got for these pixels, and use a different shade for each of them. To start though, I'm going to just use the dark 9045. So what this would be the 90, none, or yeah, this would just be an empty transparent pixel. Then it would be 90, 45. Oh, and of course these are going to want to be, you can't do color. Oh yeah, that would work. Transparent, and then it would be 90, or sorry, and then it'd be all transparent like that. So this is what the shade pixel would look like. So when I'm drawing this, what it would look like is it would be sprite batch.draw. First I'd have to copy the data over. So and what I was doing is saying get the render data and set it to the color. So this comes out as a color that I want, the base color. So I would take and set all of the indices of my virtual pixel. Actually, you know what I should be able to do is just make this an entirely white pixel. Which it might be white by default, but we'll just do this like this. I think there's a way to go through and say set everything to, yeah, set value. I want to set them across all of them though. I thought there was a way to like a clear or something like that. I'll set it. Well, anyways, I can just do it the hard way. Viral picture. Like 2012 or 2020, I meant. Set data. Yeah, okay. So what we would do is we'll first draw our virtual pixel with the position that we're looking at, which is our position, which comes through as what, a point? Yeah, so it'd be position 2 vector 2 times new vector, and then scale it out based on our 3x3 dimension. And then here's what we can do is take the color here, which should shade that pixel that color. Then what we do is we draw the shade pixel over top. Shade at the same position with the color. Now this shouldn't look correct when I do it, I think, because it needs some non-pre-multiplied alpha blending. and it's too dark for that light version of it. So blend state. Okay. Sorry, so let's just take this out of the mix for a second and say if I'm just doing the virtual pixel. Oh, you know what I did? Is I need to set this to the shade. Like that. There we go. Obviously black is too black. I shouldn't be using black as my default color. It feels a little bit... I wonder if this is taking a while to display. It feels a little chunky, or it feels slow. But that's the effect that I'm trying to achieve. So let's go to our simpler, well, let's take our color that we copied out of here and make it our actual color. So in this one, our off color is this. Oh, yeah. BCC19, okay. So we'll go into our display palette and we'll set transparent to that color. Or not transparent, right? Control C. Shoot, okay. Well, we'll do it like this then. That's the color we want. Come in here. And we will set it to that color. Okay. And our black will be set then to this color right here, which is our baseline. Zero x57, 0x55, 0x40. Not quite what I'm looking for, but I just need to adjust the shading, I think. So let's make this the lighter shade for now, which is 2010. The 20 and 10. Yeah, it's too light for the dark ones, but I think because I switched the control scheme, that's maybe why it's feeling sluggish. Well, I gotta figure out what's wrong with that. I wonder if it's taking longer to draw. No, it should be running at 60 frames per second. I can't imagine that drawing, you know, that many little pixels would do that. And it should feel just fine then at 96 by 64 because that's such a small amount. And it kind of does, so let's go up higher and see if at the max resolution if it feels the same sluggish way. Ooh. Is that really that slow? I mean, I suppose I'm doing a lot of draw. Requests. So this actually needs optimization like bad. Like I said, at this... Oh. Hello. Oh, and that's probably a, the fact that I have this running in a different thread. I need to actually have like a dispatch pipeline thing run through all the updates I want to go cross-thread, much like in the same way that you have in like WPF or some of these other things. You know, if you want something to happen, it needs to happen in the thread that's running parallel to you, not in your thread. So I have to define the boundaries of, you know, what owns what in that regards. Because yeah, that's a bug. But I think overall, you know, other than the performance issues, I like this aesthetic more. I just need to make it darker when you're looking at it from. If you have a really dark pixel. So I think what I might do is take the average and say, well, if your average color is above half of, you know, or is above 128, then use, you know, virtual pixel 1, otherwise use virtual pixel 2. And then I'm going to have to figure out why this is so slow to do that. I'm guessing that these two draws and then the blend and all that you have to do in there is pretty intense. I mean, I could slow the frame rate down, try to target a slower frame rate, but well, let's get this. We'll call this virtual pixel fade light, and then we'll make one for darker. No, this is one way of accomplishing what I want to do. I could also try to actually write out all the pixels like I was doing before, which should be doable, and then just offset it as part of that, so not rely on the so this would be like sir mean. Anyways, so I take color dot a or sorry, not a RGB, and I divide those by 3. And am I getting the byte value here? The float value. I'm getting the byte. shade is less than 128. Use this. Else use the dark shade. I might have to adjust that to, I don't know, let's say 220 or 200. There we go. So that looks a lot closer in, a lot closer anyways to what I'm looking for. But I do think I'm going to, because this is super slow, I do think I'm going to have to set the texture once and render it that way. I'm probably GPU bound with this. OBS is doing a lot, but MI83 is using 10% of the GPU, which, like I said, I don't know if it's CPU bound here. But yeah, it feels sluggish, and if I set to the top resolution, I mean, it's borderline unusable. I mean, it's usable, but it's... like, it took a human noticeable amount of time when I pressed the down arrow for it to actually be triggered. So that means the draw loop is probably in the main thread is taking up the amount of time, too much time. So let's see if I take this and if I do it the way I was doing it. And so instead of doing it this way, or I'm calling this and letting it shade and blah, 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 I bring back the idea of drawing all the pixels individually, not the viewport adapter. So I'll leave, well, I've got this saved, so render data would be max supported width times 3 times max supported height times 3. So it's a fairly large texture if you think about it. Well, anyways. So that's our two deals there. So then we go back to this. But this now needs to take into account the this now needs to take into account the fact that I can hard code these later so that they're not hard code them, pre-compute them, so I'm not computing them fly every time. But well, anyways, I should be able to. Okay, so this is going to be your position Y. Okay, so your actual color will be in 1, 2, 3 for these like pixels, and then I have to augment it slightly, or darken it slightly for the other ones, which is going to be a tricky operation. And yeah, this is a lot of going through data, but you're operating over a chunk of data that should be just contiguously there. So to compute the index in this, it's your Y position times your max supported width plus X. So this is your pixel position. So it's like our native pixel is like that. But then scaled up would be and like I said, I could probably pre-compute some of this stuff to save on the CPU cycles, but so you take that, you multiply it by 3. Or no. I gotta rethink this. So your Y will be Y times, oh yeah, and then I have the max supported width, which is actually the largest dimension. So let me think here. So your first row is actually going to be for every Y there will be 3 different pixels, and then there will be a max supported width of whatever. Right. And then your X position is really your X times 3. Now that gives you your root pixel for a corner. So if I were to do this right now without 3, and say that this is my, what we should get is We should get like a spread out array of stuff. Yeah, like this. Interestingly enough, that doesn't look quite right. Because the height is wrong. That's because when I'm multiplying it out, I actually need to go my Y position. Oh, these are multiplications commutative, so that shouldn't matter. Anyways, that looked all wrong. I is your position Y. Plus Y. Let's think this through. Plus your Y multiplied by 3 times your max supported height width. So this should give you 1, 2, 3, and then you add the next Y would be 1, which would bring you back up here, but you really need that scaled out so that this is actually times 3. So that's your Y starts at 0, 1, 2, and then on the third one, your Y gets multiplied out. Then you add on. Okay, so that gives me the correct row multiplied by the width. Okay, then what I need to do is figure out, add on to it my offset for my X. So this is actually, should just be position.x times plus X, or times 3 plus X. That should be it for that. So this doesn't feel nearly as sluggish as when I was doing it one by one. Like, this is definitely usable, unlike what it was with the other one. And I should be able to take this off. Yeah, so this is rather quick. And my CPU is only at 2.8 instead of 10%. And I'm guessing the GPU is pretty low too. Yeah, so my usage is there is pretty... And then if I take off debug, it's probably even better. But now I have to include in the additional shading and how that blending works. So I take my initial color here, and dependent on where I am in it, I I have to augment my color, so... Which, again, I could probably do this with a shader, and it would probably be much better. But I take my color, and I need to darken it if y is 0... if it's in the first two... and x is equal to 0, or x is equal to 1. Sorry, it would be just... Well, let's do it without that. So let's just get the shading sort of working. So we need to darken it by a certain amount. Now, I believe what happens when you darken something in here... so let's just take this red color, and if we want to darken it, what you're doing is you're just setting everything up by 3 or 2. Yeah, so everything goes up by 2. So every channel, colored channel, goes up by 2. So if I want to go up, and I'm not sure what the opacity and all that, but if I want to go up by 2 each, let's go with the idea that I would go, I know this is taboo, but so this would be my R. Now, when you get to a certain lightness, you can't really go up any higher, but I don't think I have to worry about that. So let's just have it go up by 20, which would really be like our 10. Well, I meant down. Down. But yeah, so that's too dark. Let's go down by tensies. Still too dark. Let's go down by 6. Still a bit dark, but not too bad. Four. And I think because I don't have that extra pixel in there to shade it differently, so this would be, well, you know what I'll just do here is if y equals 1 and x equals 1, then I'll subtract 2 off of it for now. Or add 2 back in. Which, this is ugly, but I'm just trying to get to see how the aesthetic feels if I do that. You know, it feels pretty decent, really. Sorry, I'm kind of like looking at this screen really close to see how this actually looks. I mean, I think it looks pretty good. I think I might need to go again darker if it's a dark color. So if I went like this, like took the average color like I did before. And I could pre-multiply all of this, or store it with the colored data itself or the palette. But so it would be like bar. So I go, it's less than 200, otherwise I go 6 to go a lot darker. And then I should just subtract 2 off of it here, so it would be like b minus 2. And this would be b. And again, I'm gonna clean all this up. I'm just trying to get it to work the way I want it to work. And maybe I need to go a lot darker with this, so like maybe instead of 6, it should be like 8. Or actually, let's go really crazy. Go like 20 to start. Because yeah, it's like it's not. It must not be triggering it based on that color. So there might be something that's really bringing the average down. So if I do that, it should actually have like a totally weird color. And it's not. You know what I should do is not take the average, is what I should take is the darkest color. So it's like math dot max of the RGB value. So if I did like, this is gonna be ugly, but I'll fix it again later. Because the average can be totally misleading. Let's look at our actual display code here. So this one is, these are 057, which is what in so let's just say if it's greater than, I don't know, 0x6. Just gives us what we want. come on. Why are they going all over the place? I should have a total of 2 colors in this. $173, and then the next one is $153. Oh, you know what? I'm being dumb. I'm being real dumb. So this transparent color, this was always supposed to be transparent. Right, so if I go back in time, this was the base underlying color. But I'm actually drawing black and white here, aren't I? Or no, I'm leaving some of it transparent. Okay, hold on. Oh crap, I gotta get that fixed again. No, I'm not being dumb. I'm just being foolish. So this was... shoot. 57, 55, 40. 57, 55, 40. I actually want to go if it's darker. Go darker. Okay, yeah, I am being dumb, but not the way I was thinking. It's if this is greater than some value. There we go. That is what I am looking for. And it's really should be like something like... There we go. But again, that's too dark actually. 20 is way too dark. Okay. Morning. That's too light. And then I want this one to be not -2, but b minus b divided by 2. Okay. So I think that gives a fairly good approximation of that pixelated look that I was going for. It's not perfect, but I could presumably put a little randomness into B here to make it so that, you know, some pixels are a little bit lighter, or I could do even shade this a little bit differently, so that, you know, I subtract B from just the 0, 0. So it's like y equals 0, and x equals 0, and do it like this. And this is going to get real ugly real quick, but just to prove the point, again, I'm going to clean this up. If y is 0 and x is equal to 1, then what we do is we drop it by a quarter. So b divided by 4. Or sorry. We'd want it by half of a half. So we'd subtract from it. So yeah, b divided by 4. Wait a minute. Why is these negative and these are... I want to go subtract. Right? Yeah, because I want to make it go darker. But I only want to subtract by this amount. So, gosh, what am I doing? We'll do it like this. B equals... In this case, it would be so this will even change the shade even a little bit more. Or cause a little bit different shading. Yeah, but it's a little bit too much. Now what if I make this a quarter and this an eighth? I don't think that's going to work because it'll come out with integer values, but so if I get rid of this one, everything looks all messed up again. Oh, that's because I need to... So b equals 10, so subtract 10 from it if it's this one. Oh, that's why I was setting the color each time, because b should be 0 if it's outside these bounds. So this should be else if, and then like else b equals 0. Gosh, man, I need to drink more coffee. There we go. That was the effect I was looking for. So we don't do anything here if it's 0 or whatever. Because then we just use b as is. And really what this is to say is if it's less than 2 and x is less than 2, then it's one of these values. Okay. Okay, so that I think fixes the aesthetic I was looking for. Um, Now I've got rid of the idea of having a pure black then. I feel like I could even darken that up just a little bit. Not in the shading, but the actual base color. Um, but yeah, that's fine. Um, so now the question becomes, um, so this is my largest display now. Which is, what did I say? 288 by 192. 288 times 3 is 864. So what I'm looking at is a 900 minus 864. 36 extra pixels for, well, hold on. 192 times 3 is 5. Okay. So just to put this down into words I can understand, or things. So it's 864 by 576. Now, most, displays out there are going to be, the HD size. So it's a cheap laptop, for instance. Anyways, so this ratio is what? Well, it's 6 divided by 8, right? Or is that how you figure it out? Yeah, the width's actually bigger, but 96 divided by 64 is 1.5 times bigger. 4 divided by 3 is not that way. And then 16 divided by 9, which is standard resolution, is not that way either. So what I need to do is upscale this, I think, to the closest one that matches the 1900 by that 1.77 whatever. So if we take that multiplied by what, 600? No. Well, I should be able to look at 16:9 resolutions, aspect ratios, and lo and behold, 1024 by 560, whatever it is. So 576 is a value, so I'd have to upscale this to 1024 as far as my width goes. So let's set that to start us off. Okay, I'm going to delete this extra crap that I'm not going to use now because that was definitely too slow. Did I ever set the explicit resolution on this? I didn't. So let's say that the whole thing boots with graphics dot preferred back buffer width of 1024 and graphics dot preferred back buffer height of what did I say? 576. that way, if I go up to this size, it should be stuck there. And if I expand this even a little bit, it's just, yeah, it's off the edge. Yeah. So I could make this kind of like my minimum resolution. But then what I need to do is say, well, what happens when they go to, or when they're at these smaller sizes? What I could do is scale that, which is going to make the pixel values a lot more apparent. A lot more. And what I mean by that is I start here and I say, okay, have my source rectangle position, float rotation is 0, origin is 0, but my scale is based on this vector. And that I would set based on, so this is 1.5, I think, for the default. And I'll have to adjust this. Oh. Come on. Oh, now what am I? Come on. Oh, I suppose with this particular mode of using a vector 2, I can't use this, so it would be oh, weird. Okay, let's undo this. And we'll just change this to be 1.5 up here, because I'm not going to scale them independently. Okay, our origin is... It's hard to get these things in... shoot. That's stupid S. It's hard to get them in order, because there's so many close, like, differences. Okay, so this takes that default value and scales it up. It doesn't scale it up pretty, but it scales it up. And it could be that that's just the way that this point clamp works. I wonder if I change this to be just the default, how that would look. It's not going to be crisp, it's not going to be pixel perfect. Yeah, it'll be blurry because of the shape of things. But maybe blurry isn't bad in this regards. You know, but this should be fairly crisp. But that's because it's scaled up when it shouldn't be. Because it's a static size, so it's like I need to take the dimensions of the resolution and then figure out what the X value is. So it's like I came to this 1.5 by taking you know, the, what was it, our max resolution is 288. So if we run 288 divided by our current resolution, which is 192, we get the scale up. So I should be able to do that thing where I take the max resolution, which is what I have on width. So it's like max width. And then divide it by the actual current width. And that will give us the proper scale. So by default, it should be scaled up. I go down to this, and then I get really scaled. And then I go to this, and then it's pixel perfect. I don't know. I have to figure out whether I like this aesthetic or not. Oh, and then yeah. So this is when I'm scaling down at certain times. I have to have the idea that the display here and its interactions, they have to kind of be locked during a frame. But I guess, you know, the question becomes, is this aesthetically pleasing for people that might be using this? Now, the other thing I could do is put back in the virtual deal here as well, so that it positions it correctly. Let's try that once. So our desirable size is actually always that. Let me bring this back. Nope. It's going to begin twice. And I might want to take that point clamp off, but maybe I'll see how that feels first. Okay, so this positions it correctly. That is ugly as sin. And actually, shouldn't this create new fit in that size? Yeah, there's something off. Oh, yeah, I've got to reset this. And it probably should be set to ×3. That was ugly. No. Why is that doing that? Well, it was already doing the scaling. So maybe I just don't need the viewport adapter at all, and I just do this my own way. So we get rid of this. We still will eventually need this down here, but Let's try various sampler states here and see how they feel. So this is point wrap. Yeah. I actually think the amp trio stropic amp, which is probably the default. It's probably the best bet. Again, it provides a little bit of a... it's blurry, but I don't think that the blur is that big of a deal, because I mean, if you were looking at it on the calculator, it would be kind of blurry. They always were a little bit blurry. So what I need to do here then is to say, well, if I resize the screen, how does that affect it? And then the other thing I would want to figure out is how do I make sure that it's always centered. So at the max resolution, it's not blurry at all. I'm going to also adjust this color out here too, because I don't like that color being so distant from the more muted color that I have now. Let's see, did I take a screenshot of the outside of that? Or did I only get the inside? Yeah, so I might need to go back and find that image yet again. TI-83 display images, and I said that they were large, and then I found the one that was right here, I think. I took a screenshot of it. Or how about I take it of this corner where the light's less flashy. And I plop it in here. And then I take a multi-pixel average of that color. A9CO98. A9 CO. Let's see, the third one was 98. Now that was off the other side of the screen, so maybe it won't come out very nicely. Yeah, see, it's a lot greener than the muted color I had. So let's take it from B3C4A2. 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 Not a bad number. Easy to remember. Yeah, it's not quite not quite the same, but I suppose they could just make it so that it's actually a shade. Well, let me look at what the base color I'm using here and then go a shade off of that. Because really this should be just a shade lighter if you look at the way that it actually sits next to it. And that's because there's no pixelated value on it. So our displays is this. So we'll go a shade lighter, which should be to C to A. This would be C0, but then would be BF to go to a shade down, and then this would be 9A. Yeah, so that's pretty close to where I want it. Yeah, I'm not sure if this is coming across very well on the stream, but the other thing I want to do then is take this dimension that I have and center it. So what I have to do is take my actual width here, which is my max width times 3, and then subtract off. So this would be new vector 2. The Y would stay the same, but this would be my computer display resolution. Actually, be my max resolution times 3, and then I would take the actual viewport width. Subtract off this. Divide it by 2. That's how much I'd offset it. There, we got our centered screen now. Now if I scale it down, obviously that's now broken. I mean, it centers it, but it's broken in terms of if I go too tall, obviously then it's so what this should be doing is filling up most of this. I also wonder how this is going to look like when I actually put colors in. So maybe that should be my next step here, is to get a sprite drawn. There's a lot of flicker too in the way that this gets drawn. Now the thing that I should do is make it so that is to change it so that when I draw like that, it's not actually, because what this does is it clears out everything, and the flicker we see is because there's a, like I've got 2 threads running independently and they're not synced up with each other. So when it clears out that buffer, I mean, you could draw it mid-clear, which isn't exactly great. You know, one thing I could do here is to make it so that so a lot of these times I'm doing in like the home screen, I'll have where I am waiting like this for something to happen. This thread sleep, and then the while not end. What I could do is have a I could have a build out a specific waiter that what it does is, or not waiter, a specific thing that says when the update loop in the main thread like this triggers a counter flag or something like that. So how a wait would work would be is that it would go get the current value of the like clock, which should start at 0 or whatever. Get the current value of the clock, and then while the clock value stays constant, just sleep. And then as soon as the clock value increments, then it will allow a loop. That really doesn't gain me much of anything, though. I'm just thinking about this now. What I need to do is make sure that when code is executed in here, any of these particular things, that they aren't run in the thread that the code is running, that they actually run synchronously in here. So what I could do is structure the home screen like the code here. Let's just take something like clear. So when we clear, what we do is we take the contents of clear and we pass that into like an instruction register type thing to say I'm not actually going to execute the clear functions in this code. What I'm going to do is put them into a like an execution buffer of sorts. And then what will happen is that the update loop here will run through those updates and execute them in its thread time. Now, how would that work for stuff like this where I'm waiting for something? That is a good question. How would that work? I don't know. I'll have to think about that. That would be a refactoring for another day. Let's just keep on the task at hand, which is some of the aesthetics here. Now what I could do is choose to not scale this up like this and instead put like a take the same dimensions and then scale it to only how much I'd want to scale it. So maybe I scale it up only to this size, but then I actually, and they can't see me doing that, but I actually put it like in the middle here. If that comes through, I don't know if that comes through when I did that or not. Actually, it doesn't. Probably when I'm taking a screenshot. Oh yeah, it does. But just put it as like center it within the greater bounds of max so that it's not so ugly. I don't know. But I am pleased with the aesthetic that I was able to achieve with this. So, do I want to get scaling working like this right now? You know what? I think I am going to not say that. I think I'm just going to disallow user resizing for now. And I'll add this in as a feature later. So it'll be stuck at the resolution that I give it, which is the 1024 by 560 76, which is a 16 by 9 resolution. So I think that'll be fine. And then I will also allow a full screen mode. I gotta figure out how to get that cursor to go away too. Like I said, it can also make it so that I don't have to, when I do this, I don't clear the entire buffer every time, but Should make it so that that edit goes right into this. Ooh, yeah, because I didn't clear it. You know, pretty much all my programs are starting with clear home like that. I wonder if I should just make clearing home part of the... you know, no. You know what? I don't want to do that. Because then, like I said, if you do a sub-program that where you're collecting some data, then it would break. So... something I do notice here now that I'm doing this is that, so this crisps up to the end so perfectly. I'm wondering if I shouldn't put, I could actually make this additional space here that isn't part of the actual console itself. Just not one that you display normally. So it'd be part of the texture that gets drawn. And then it wouldn't look so like crisp on the edge for where it's scaled out, but I don't know. All in all, I think I'm good with this for now. I need to obviously I might need to optimize some of this stuff later, but for now I'm going to call it good. So screen drawing, make pixels visible. Okay, so I think next stream what I'm gonna do is get back into looking at oh yeah, did you see that ugly amount of garbage collection I'm doing as well? I'm going to look at the graphic screen implementation here. Oh, I need to change this to be, update this to be accurate too. This is no longer, what did I say? Man, I cannot remember. 288, 192. 288, 192. And then that would be, what is it, 80? 48 by 6, 48. Oh, I got that all wrong before. 48 by 92 by 8, 24. Yeah. So I've got all of these update. Okay, what did I do wrong? Well, it'll be stored in there somehow. Okay. So I've got to get all of these ones. So clearing the draw, which will bring in the graphics screen, taking a picture, and recalling. I'm going to have to think about if you were to change resolutions during the middle of that, how that would operate. Or if you pulled back a pic from some other one. So sprite would be probably the last thing that I do. Stroke and fill are going to set the colors at which you draw so stroke would be for like circle and rectangle and lines and pixels, and then fill would be for circle and rectangle. So basically I've got to get those. Now line drawing isn't an easy task, actually. It's quite hard from what I understand. There's algorithms that I'll have to go look in, and circle drawing is the same. It's not a simple task. It does take some, like a specific circle drawing algorithm, because you're taking something that is perfectly seamless and converting it into pixels. So I believe anyways. But so I think the graphics screen will be the next thing that I do. And like I said, then the sprite thing will be the last thing that I do. Because the sprite buffer then will have to be created, and I'll have to figure out with sprite buffer how to actually store those sprites in the code or in the memory or whatever. Which right now, you know, it's these PRGM files, and they are literally just the Python code, you know, straight up. So yeah. Okay, well, I think I'm going to call it good for right now. It might be on later today, or it'll be tomorrow that I stream next. So have a good day.